All right, well, it's 1:15. I guess we'll go ahead and get started. My name's Doug Fitzpatrick. I'm a structural engineer with Fitzpatrick Engineering Group. We've been using BIM now since the tail end of 2006 or so, and have been interested in trying to figure out how to leverage what information we have in our model to kind of make the steel industry better, more efficient, gain market share, all that kind of stuff. So today I want to share with you what we're doing with the steel fabrication package and explain kind of how we're going through this process. And it's been a slightly controversial issue, engineers doing shop drawings, so hopefully by the end of all this you'll see it's not as bad as what some might think it is. So hopefully everybody's all gassed up from lunch and I can get through this quickly and before the lunch coma kicks in. So a couple things I want to cover today. Talk a little bit about the current process of creating a fabrication package. Discuss this new workflow, what our proof of concept is, and we'll look at a couple case studies. We'll look at the ramifications of this new workflow, the intentional consequences that we tried to solve, and some of the unintentional ones. And then, if we have time, hopefully I want to talk to the engineers in the room about what all this means for them. So, show of hands real quickly. Engineers? Okay. Fabricators? And detailers? Okay, about a third. So before we start, here's our PDH code. I'll go ahead and I have this on the last slide as well. So 25796. I changed the name. A lot of things have changed over the last year since all of the sessions for these things are done almost a year in advance. And I had shop drawings written before, but it's really a package. There's a lot more involved in just getting paper sheets from somebody for fabrication. There's a lot of other information that really we engineers don't know about, probably need to know about, that kind of make this thing want to be more of a package than it is drawing. So that's why I changed the name to package. Again, I'm going to be speaking in generalities here. There's a wide range of who's doing what and who's capable of doing what, and I'm going to try and keep this going right down the middle of the road. So if I say something that says, well, we're not doing that or we are doing that, it's not intended to be a personal thing. It's just I've got to have some road to travel down, and I'm just going to try and stay down the middle of the road. Some people are doing some very sophisticated things, and some aren't yet. It still takes a long time for everybody to get up to speed with these things. Secondly, AISC mission statement. This comes right off the website. Basically, the short answer is, how can we make the construction industry for steel buildings quicker and more efficient to gain market share? It doesn't say how we do it. And I think that what I'm going to show you here today is a way of making the fabrication process more efficient and leveraging the efficiencies that are already in the process to help increase the market share of steel. So my argument today is going to be that the current process of generating the steel fabrication package is rooted in and handcuffed by an outdated set of procedures and protocols that hampers the efficiencies today's technology will support. And so I'm going to share with you our solution for that and the new efficiencies that's going to bring to the table. So kind of as a framework for how I'm going to tackle this issue is we're going to break this up into 4 steps: the design process, the detailer's model, the review of the detailer's model, and fabrication. And for design, I mean 2D delivery, 2D production of 2D documents for construction. There are a few projects out there that are trying to do some different things, but generally speaking, 2D documents is what controls. So that's where we're going to start with the design. The detailer model is basically recreated from 2D CDs, and we'll talk about that for a minute. And then review, we'll say, is generally non-paper. I think it's not very often we see a roll of drawings come in anymore. A lot of that is is electronic, and we're going to talk a little bit about that. So we'll start with AISC workshops that have been going on for about a year. So generally speaking now, in the early days, 2D documents control, the detailer recreates their detail model from our 2D drawings. So when we get a set of shop drawings now, and we'll just say paper at this point, that the engineer of record has to check all these things. There are probably more things. You could say I ran out of space, whatever. These seem to be the ones that came to my mind. You know, section size, length, camber. I mean, you can read them all there. A lot of these things, you know, we had to go back through and check to make sure that somebody took our 2D drawing and recreated the 3D model, spit out their 2D drawings, and it matches what we had on our construction documents. Pretty traditional. You know, so engineers got really good at being able to take all these 2D things, put them together in their head, and make sure, you know, see if all these beams match up with the columns and the connections match up and all that kind of stuff. You know, granted, it's gotten easier with the advent of 3D modeling for the detailer, but nonetheless, you know, if we're looking at our 2D drawings, you know, we have to put all this stuff back together in our head. So the workshop stance was, isn't this a heck of a lot easier? So this has kind of been coined the hybrid approach, where you're not necessarily reviewing the model and making changes or comments in the model, but you have this 3D picture or model that you can zoom around in and kind of see how all the pieces go together. You can annotate these with their mark numbers and whatnot. So, you know, picture's worth 1,000 words. So for us, what happened with this hybrid procedure approach is now all of a sudden, you know, we're getting some visual checks here. You know, the detailing models allow attachment of reference files, so we can actually take our DWGs of our plans, lay them in there, and kind of see, turn the model attributes on, and compare them against our attributes in our 2D plans that we sent over. So some things start to become visual and easier rather than back and forth between sheets and sheets. So full model review is a step further. This is where everything is done in the model, everything. So RFIs are dealt through there, questions, comments, review, markups, all done electronically, saved in one place. You know, some of you may be familiar with this. And there's a couple ways to do this. You can transfer files back and forth by basically making a copy of the model. There are some different ways of sharing the markups that we would make back with the detailer so that he can read those into his model and make the changes. Some of them might be full access via remote admin, where, you know, VPN or whatever you want to call it, you can actually work on the model that they're currently working on and make changes and leverage all of the tools that they have to work with in read-only mode, you know, not in writing mode. And then maybe some desktop sharing, you know, is another option. But the power here is really visualization and being able to annotate these things in the model. And, you know, just like everything else, a picture's worth 1,000 words all of a sudden. You can kind of see how things go together. There's all kinds of filtering and statusing that you can do to kind of see what's going on. So if this was a simple little model from the detailer, we can look at things that are galvanized. We can look at approval status, things that we've approved, things that are not approved, need to be resubmitted, you know, whatever. Things that have review comments on them. You know, it really makes it easy for visualizing what's going on. So now if we take this a step further and say, well, if we're doing full model review, you know, now what's happened? Well, this part of it is still basically the same. You know, we're still having to look at section sizes, length, camber, all these other things, but we've saved a couple trees in the process, right? Which is a good thing. And what this has done now is kind of help this review portion of it. You know, there's no longer the sending paper back and forth. You don't have your red magic marker and your yellow magic markers out. You know, you're doing a lot of this stuff in the model and expediting the review process. But for us, we think this is just kind of nibbling on the real problem.